Hey math students, Miss Patterson here. We are going to continue our lesson on domain and range by thinking about domain restrictions and how only certain x values are allowed into certain functions. Before we get into that though, we're going to complete this warm-up. So for each of these graphs, I want you to find the domain and range for the following functions in interval notation. So make sure to have your other notes out from the previous video to help you with this warm-up. Try this on your own for about 5 minutes, then come back here and we'll go over it together. So what I got for this problem is this. These are my domains and ranges. In case it's a little hard to see or in case you can't remember, so this first one I think is the easiest problem. You would only get it wrong if you forget that you need to put arrows on the end if the function goes all the way to the edge of the graph. And so that means since there's arrows on the end, the domain goes all the way there, and then your range goes all the way up like that. Okay. This middle one was a little tricky because of that hole. So the domain, we have a closed circle there, and then an open circle at -1. Then it continues on to an open circle at 6, which is why I use brackets, and then a parentheses at -1. This means just and. It's a little u, so that means and. We continue from -1 with a parentheses because of that hole, all the way to 6 with another parentheses. So the bracket corresponds to the closed circle, parentheses corresponds to the open circle. The range is a little tricky with those holes. So the lowest point is at -5 with a closed circle. And some of you might want to do an open circle because of that right there, but I can see at -3 there is a point, so we can fill that closed circle in because there is a point at -3. And then same thing up here. It might look like it's supposed to be an open circle, but I see that there is a point at +4, so we keep going up to 5. So that's how I got a domain from -5 to 5, because there were points in the range at -3 and 4. That one's a little tricky. And then finally, we had this square root function. So the domain for the square root function starts at 0. And then we can, since it goes off the edge, we can assume there is an arrow there. And then same thing for the range. It starts at 0 with a point, and it goes off into infinity because of the arrow. Okay, so I noticed that in some of these graphs, particularly the square root, there were certain x values that weren't allowed, and that's because the square root function, in this case, doesn't allow negative numbers, right? That's why there's no numbers that are negative, because square roots don't allow you to put negative numbers in. So we're going to focus on 3 functions that are like this. Okay. So like I just said, some functions only allow certain x values inside, meaning they restrict the domain values. So these are called restricted domains. And this also leads to the, this also leads to the range. I meant to say range here. Being restricted to certain y values. Okay? And so those 3 functions are the square root, the reciprocal, and the log. So we just looked at the square root. With square root functions, the restriction that you can always remember here is that x has to be greater than or equal to 0. Okay, so anything under a square root, anything in that square root has to be greater than or equal to 0. And so, like we said in the warm-up, that is how we get the domain going from 0 to infinity. 0 to infinity. And because I only have numbers 0 to infinity in the domain, that affects the range and makes the range only go from 0 to infinity as well. Okay? The middle function is the reciprocal function. I don't know if you've seen the reciprocal function before, but basically the reciprocal function is the reciprocal of y equals x. It's the reciprocal of a line. So instead of being y equals x, it's y equals 1 over x. Okay? Reciprocal, flipped. And so the restriction here is that you're not allowed to divide by 0. And so whatever is in the denominator cannot equal 0. Whatever is in the denominator cannot equal 0. And so that's how we get this kind of weird looking domain right here. So we go from negative, I want you to be able to see, negative infinity to 0. And then the graph stops. You see how the blue graph stops? And we have that asymptote. And then it continues from 0 to infinity. So that is how I get this two-part domain right there. Negative infinity to 0 in union with, or and, this u, and 0 to infinity. And so because I have that restricted domain, it affects the range and allows the range to only go from negative infinity to 0 and then 0 to infinity as well. Okay. And then our final restricted function is the logarithm function. And so for logs, logs are inverses of the exponential. So this is the exponential graph, but the inverse of it. And for logs, you can see that a log has an asymptote as well. Whatever is inside the argument, whatever is in the parentheses here, has to be greater than 0. So the log is never equal to 0, it's always just greater than 0. So it starts down here. It's not equal to 0, I'm using an open circle, and then it continues on to infinity. And that is how I get this domain right there, that restricted domain. Okay. Just to review a little bit of vocabulary, these orange lines on the graphs, so these orange lines right here are called asymptotes. Oopsies. These are called asymptotes. Okay? And asymptotes are just invisible lines that the graph gets really, really close to. So the graph is always getting closer and closer and closer to those asymptotes. And the distance between the graph and the asymptotes are getting closer and closer to each other. I know that you all know what the domain is. The domain is all the possible inputs for a function. And I know that if I were to give you a graph, you would be able to look at the graph and determine what the domain of the function is. However, domain restrictions are when you're able to look at an equation and know all the values for which the function is undefined just based on the equation. And this is a really important skill because you're not always going to have a graph and you're not always going to know what the function looks like. But you will want to know what is the domain of this function, for which values of x is this function defined. And so when we're finding domains analytically from an equation, there are 3 rules that you need to memorize in order to know what are the values for which this function is undefined. The first rule is that you're not allowed to divide by 0. Okay, dividing by 0, that's not allowed. And so the types of functions this is going to affect are reciprocal functions. So rule number 1 affects reciprocal functions. Okay, and we know reciprocal functions look like 1 over x. So in that case, I know that x cannot equal 0. That is the restriction, the domain restriction that I'm putting on the function. If the function is 1 over x, I know x cannot equal 0. And it's really similar if I were to make this slightly more complicated, like 7 minus x. Then I know that 7 minus x cannot equal 0, so x cannot equal 7. So x does not equal 7 would be the domain restriction there. All right. Second rule, taking even roots of negative numbers. So if you have a square root, you know that you're not allowed to take the square root of -4, for instance. The square root of -4 is an imaginary number. It's not a real number. And so that is not in the domain that we want to include. So for number 2, this means even roots. So an even root would just be like the square root or the 4th root, right? Or the 6th root. You get the picture, any even root. And so if I have the square root of x, if I can't take the square root of a negative number, that means that my x value has to be greater than or equal to 0. So this would be my domain restriction. X is greater than or equal to 0. If I had something a little bit more complicated, like the square root of 1/2 x plus 3, then I know that 1/2 x plus 3 has to be greater than or equal to 0. If I were to simplify this and solve for x, then I know that x is greater than or equal to -6, and that would be my domain restriction. Okay, and then the third rule, a little less common than the first two, but you cannot take logarithms of non-positive number. So this vocabulary word, non-positive, a non-positive number is any negative number and also 0. 0 is neither positive nor negative, so a non-positive means a negative number or 0. So that means this affects my logs, obviously, and my natural log, my ln. So that means that if I have ln of x, or any log of x, that x has to be greater than 0. It cannot equal 0, it just has to be bigger than 0. Then again, if I had something slightly more complicated in there, maybe I'll do a log this time. So log of, I don't know, x minus 12. That means that x minus 12 has to be greater than 0, so x is greater than 12. These are very basic examples of domain restrictions and how you can figure out the domain based on the equation. For most other function, the domain will just be all real numbers, -infinity to infinity. These are the functions that you should memorize, because then you know, oh, if I have a reciprocal, a root, or a log, then I have to figure out what the domain is. Otherwise, the domain is just -infinity to infinity. The only other, there's one other case if you have a piecewise function. So piecewise functions, you might need to check on that if they don't meet up in the middle. Okay, so let's look at some slightly more challenging examples, but not really, I feel like you got this. So determine the domain restrictions for the following functions. I see that I have an ln, so I need you to try not to look at your notes and think, all right, what numbers are not allowed to be in a log? Okay, so inside the argument, remember you need only positive numbers. You can only have positive numbers in there. Okay, so that means that x minus 3 has to be greater than 0. So the domain restriction for this function is that x is greater than 3. For a reciprocal function, remember the denominator cannot equal 0, so can't divide by 0. So that means x plus 2 cannot equal 0, which means x cannot be -2. That is my domain restriction. So it's all real numbers except x cannot equal -2. Finally, a square root. Square root, you can't have negative numbers. So no negatives. No negative numbers. So what's inside of there? 2x plus 1 has to be greater than 0. I made a tiny mistake there. Can you tell what I need to add to my equation? It can be equal to 0. So square roots, you can take the square root of 0. That's no problem. So in this one, it can be equal to 0. If I solve this out, I'll subtract by 1. Then divide by 2. So x is greater than or equal to negative 1/2. Those are my domain restrictions.